Okay, for the second part of this lesson, we will go ahead and start with a simple task. If you could get a piece of paper, preferably a graph paper. If not, a loose leaf paper would work, lined or just a blank sheet of paper would work too. It's all good. So what I would like you to do is that I would like you to split the paper into two halves, the top half and the bottom half. For the top half, I would like you to write down y it's equal to x squared. And then for the bottom half, so somewhere, oops, sorry, somewhere in the middle, we can just write down y it's equal to x cubed. And then on the left-hand side, I would like you to go ahead and draw a pair of axes, the x and y axes. I'm just gonna duplicate this and then put it here. So give yourself maybe 30 seconds or a minute to sketch. Now, just to sketch this graph, these two graphs. All right, so you may pause this video and do that. Now, for those who have no idea how to draw these two graphs, that's fine. Okay, I was like that before. So what I would recommend you to do is that on the right-hand side of the paper, go ahead and set up a table. Okay, so we will write down some x and y values. Okay, first some x values. Let's start from -3, and then go to 0, and then 1, 2, and 3. And you will go ahead and get the y value based on the equation. Okay, and we will do the same thing for the bottom equation, right here. All right, so that should be nice. So yeah, just go ahead and pause this video, sketch the graph, or if you cannot sketch the graph, go ahead and get the values, get the y values, and then try to sketch a graph. Now, here's the thing I want to make clear, and that is I don't need you to make a wonderfully drawn graph. Okay, it's just a sketch. If you can provide the general shape of the graph, it's all good. Okay, so go ahead, pause this video and try it out for yourself. All right, so assuming that you have done your work, so let's go over these table values first, in case some of you might want to double check the values before you plot the point. So -3 square, it's 9, -2 square is 4, -1 square, it's 1, and then we have 0, 1, up 1, 4, and 9. Now, the shape of the graph should look something like this. Okay, so in Algebra 2, you should have learned about the quadratic equation and parabola. So we have that. Okay, we have that right there. All right, so that's the shape. Now, whenever we draw some graphs, we should ask ourselves a question. Why does the graph look like this? Okay, well, if you have the table with the values, then you have a better time to explain to yourself. That's number one. We can ask a question such as, hey, how come there's nothing right here at below the x-axis? Why is that? Okay, we can ask this kind of question. And we say, oh, yeah, there's nothing below the x-axis because the y value cannot be, negative, since any number multiplies by itself must be positive, right? So it doesn't matter if you have a negative number or a positive number. If you multiply by itself, it will end up to be positive. So that's why there's nothing down below underneath the x-axis. Okay, so we can ask questions like that. And we will go ahead and write down some values for x cubed. And that is -27 -8, -1, 0, 1, 8, and 27. Okay. Now, again, we're just trying to sketch. So you don't have to draw those marks on the axes and try to be very accurate. I mean, I appreciate that attempt, but for this particular graph, it's going to be a little bit challenging because we have some pretty negative values. Okay, so we say, it will start somewhere right there. And then it will go like this. So it's like a little S shape. That kind of graph goes down on the left, it goes up on the right hand side. Okay, so something like that. So if you can sketch this kind of shape, it's good. It's very good. Okay, and we can ask a question such as, hey, how come this part of the graph, it's I mean, how come the x cube graph how come it is starting on the lower left corner, lower left quadrants, we say. Well, and then we say, well, a good way to explain it to ourselves or to any other person is that, well, think about this. Just think about this, all right? If you have a negative x value, okay, let's get a nice number. Let's just say it is -10. -10, all right? Say -10 right here. What would be the y value if it's -10? Okay, so think about this. What would be the y value when it is -10? Well, if the x value is -10, the y value will be -1000. And if it's 1000, it will be the point will be all the way down. Okay, so what I want to illustrate here to you as a beginner, warm up, whatever you want to call it, is that I want you to understand that we are not trying to force anybody to remember the shape of the graph. No, not really. But rather, we would like you to understand that, hey, the graph is just a reflection of the values of the function or equation. Okay, that's what we want. So if you have trouble drawing some graphs or sketching some graphs, a very good place to start as a safety net is that, all right, let's think about this. If I can hypothesize some x values, would I be able to get the y value? If the answer is yes, then, well, let's go ahead and do it. Let's go ahead and get some points. And then we can at least get a general shape of the graph. It works for all kinds of functions that you're about to see for this course. And it will get you really prepared for the upcoming topics in pre-calc. Okay, so we have that. So now let's, after we draw these two graphs, and let's go ahead and focus on the top graph first, the top function, the y equals to x squared. Now, what I would like to do is this. I would like to do, I would like to observe the graph. So let's take a look at the graph. Okay, do you find the graph pretty symmetrical, like a reflection of something? Okay, so take a look. So if the question is, well, if it's a reflection, what is the reflection over with? Okay, so we will say, oh yeah, you know what? This x squared function, it is reflected over y-axis. Okay, it's reflected over y-axis. Pretty easy to visualize this, right? So, right, so we have observation done. All right, next up, what do we do? Now, if you're okay with y equals to x squared, I would like to say, are you okay for me to write this? Okay, well, I mean, it's a function. So let's go ahead and write down f of x is equal to x squared, right below y equals to x squared. The reason why we would love to have this kind of notation is because we are going to put some x values in here, and with function notation, it makes our picture, our notation really, really clear. Okay, all right. So let's make some statements here, mathematical statements. So based on the graph and also with the help of the table on the right-hand side, let's make a couple of statements here. I can see that f of -2, it's equal to 4. Okay, you can see that from the table right here. F of -2 is equal to 4. So again, with the function notation, it makes it really, really clear that x is equal to -2. And hey, what's the y value? What's the function value? Oh, it's 4. Okay, clear, very clear. And I bet you realize this too, which is that, hey, that's another x value, which will give you the number 4, which is f of 2. It's equal to 4. Okay. Now, what is really, really interesting is that, hey, can you see that it's not just the 2 and -2 that share the same function value? Like if you put -1 and 1, f of -1 and f of 1, hey, they share the same function value as well. And we say, hey, look at f of -3 and f of 3. Hey, they share the same function value too. That must be something so special, something very, very special. So we say, well, we can make a statement right here. We can say, hey, guys, f of -2, which is 4, it's equal to f of 2, which is also 4. Okay. So it's a fact. Okay. It's a true statement. So that's why we could write this down. And as I said, well, not just -2 and 2, it basically works for any x value and the negative x value, right? So we can actually go even further and say, hey, f of -x is equal to f of x, right? F of -x is equal to f of x. Well, that's actually very powerful, okay? Because it shows us that, well, I can see the graph that is a reflection over y-axis. Well, how can we write it with notations? So this notation right here, is to show us that, oh yeah, the graph is reflected over y-axis. Okay, f of -x, okay, there's a function value. Oh, it's exactly the same as the f of x. Okay, they share the same function value. And the only time it is true is that, well, it's reflected over y-axis. If it's not reflected over y-axis, this statement would not be true. So let's give this a name because it's so special. It's so special. Let's give it a special name. And we say, what kind of name could we get? Well, if you have a graphing calculator, okay, or you can use Desmos or GeoGebra just to make some kind of graphs. And what you realize is that, well, any x to the power of an even number, like x squared, x to the 4th power, x to the 6th power, x to the 8th power, x to the 10th power, hey, they are all reflected over the y-axis. Like if the power, it's an even number, like by itself like this, if the power is an even number, hey, we've got ourselves a reflected a graph that is reflected over y-axis. Well, since it's so consistent with the even numbers, how about we call them even function? Okay, let's call this kind of function an even function, right? So that's how it earns its name, called an even function. Okay, all right. So f of -x, it's equal to x. It's an even function. Now, later on, you will have some exercises, right, on the worksheet. And we would like to find out whether a function is an even function or not. So the way we do it is that instead of x, let's go ahead and put it -x into the function. And we'll see. We'll see if it is the same exact look as the f of x. If it is, wonderful. If it's not, oops, something is off. Okay, it may not be an even function. Okay, well, we have another situation. Well, I guess you may see what's coming up. Now let's look at this graph right here, and we say, it looks somewhat symmetrical. Don't you think that way too? It looks somewhat symmetrical. And we say, well, what is it reflected over with? Okay, I'll give you 10 seconds to think about it. Okay, so do you know what it is reflected over? Mhm. Okay, so it's not reflected over the y-axis. It's not reflected over the x-axis. Some of you may think, guess, that is reflected over the y equals to x. Well, if it's reflected y equals to x, then there will be a graph going this direction. But that's not the case. So it's not reflected over the y equals to x. Well, it's reflected over the origin. Okay, it's reflected over the origin. And that's the reason, actually, why the values are negated. If you have a negative x, then you have a negative y. So you can see -3, -27, and here we have 3 and 27. If you negate the x value, you also negate the y value. So let's go ahead and do a similar practice as we did earlier. We say, oh, yeah, let's go ahead and do a f of x is equal to x cubed. Okay, just go ahead and change this notation a little bit. And we say f of -3, it's equal to -27. And then we have f of 3, it's equal to 27. So what kind of statements can we write here? We can say, ooh, f of -3, it's -27, right? So it must be negative f of 3. And this is true, not just for 3 and -3. It's also true for 2 and -2, 1 and -1, right? So we see a general pattern right here. And therefore, let's go ahead and make a generalized statement, which is that, hey, if we negate the x value, what's happening to the y value? Oh, the y value, it's also being negated compared to the original function. Okay, compared to the original function. So, well, again, if you would like to get your graphing calculator or graphing utility and try it out, x to the 3rd power, x to the 5th power, x to the 7th power, you would find similar finding that they are all reflected over the origin. Now, of course, there are more functions that are considered this kind of function, okay, and also the even function. There are more functions, not just these guys. So we call this odd function. Okay, we call this an odd function. So that's it. Okay, so that's the introduction of the odd function and even function. So what I want you to understand here is this. Now, if you just look at this notation right here, all right, it could be a little bit intimidating because it's kind of hard to see. And that's why I provided this table right next to the graph, okay, before we make any kind of generalization. And with this kind of table with the values, you can see a lot better what is going on with these values. And I hope that it makes a lot more sense with these two types of function. Now, if you wonder, like, okay, so let's just say I get what it is. What is an even function? What is an odd function? Like, how good? What is the usage of these functions? Now, well, we want to describe functions more, and sometimes you may not have a graphing calculator right next to you, so you may want to have some kind of method to see if the graph is being reflected over the y-axis or the origin. You want to have that kind of method to see it. And this is the method. Go ahead, substitute the x with a negative x, and we can see that. We can see that whether it's an even function or odd function. Okay. And in calculus, actually, we will make use of these functions, these notations to help us out in finding some very interesting areas under the curve. So, well, that's the calculus part, which you will see a year from now. Okay, so let's go ahead and try to do these exercises so that we can see what's going on. Now, I'm just going to do a part A real quick. Okay, now let's go ahead and hypothesize what we anticipate to see. Now, if it's an even function, okay, if it's an even function, what we will expect to see is that, f of negative x would equal to the exact same thing. Okay, if it's an even function. Well, what about if it's an odd function? Well, if it's an odd function, well, when we put in the negative x, the whole function will be negated. So that means all the signs will be flipped. So instead of positive x to the fourth power, we'll have negative x to the fourth plus 3x squared minus 5. So these are our two possibilities. And if the outcome doesn't fit to any one of these two, then we'll say neither. Okay. So let's go ahead and try out part A and see for yourself. So we'll say, all right, let's go ahead, put in negative x into x, and let's go ahead and check it out. And again, remember, we always use parentheses, okay, as a good habit to substitute so that it creates zero confusion. All right, so now you may want to pause this video just to see if you can do this all by yourself. Okay, and I will keep going. And when you're ready, you can resume. All right, so negative x parentheses to the fourth power. So the whole thing, the whole negative x is raised to the fourth power. Well, it's positive. Okay. And then minus 3, well, negative x squared, it's positive x squared plus 5. And we say, ooh, so if I put negative x into x, so f of negative x, it looks the same thing as the f of x, x to the fourth minus 3x squared plus 5. So even though I didn't graph it, I have the ability to say that, oh, yeah, this is an even function. And it is reflected over the y-axis. Okay, now, if you don't believe it, we may go ahead and graph it at your own graphing calculator, or I can show it to you with my graphing calculator. We'll say y is equal to x to the fourth power minus 3x squared, and then plus 5. And you can see that, hey, it is really like a reflected graph over y-axis. So you can see the power that we can have with just the algebra. And we can say, oh yeah, if you just go ahead and substitute, okay, you can see the outcome. You can see the outcome. And the more you do, you may actually get a little bit of hints. You may develop some kind of shortcut to tell whether it's an even function or odd function. So the hint is maybe you do the steps mentally and you may be able to see it. Okay. So if you have any question, make sure you ask in class. And I hope you understand what is an odd function, what is an even function. And I hope that these two notations are not some strange, weird mathematical notation that you have no idea about. Okay, if you ever get confused, make sure you use these two examples to get your memory back, so that you will totally understand what's going on for an even function and what's going on for an odd function. All right, so we'll go to the next lesson soon.